get up my bits. Okay, let's start zigging again. I am kind of curious if what other lings exist. Let's have a look. What other lings do we have? Let's put you over there. Yeah, what other lings do we have? Bashlings? Because you can test in Bash, right? Yeah. About Golings. Yeah, there's a Golings. How many exercises? They're all labelled differently then. Okay. Maybe we'll create a Bashlings at some point. Anyway, let's continue with where we left off. We got all the way to exercise 16. So, let's have a look. For loops also let you use the index of the iteration, a number that counts up with each iteration. To access the index of iteration, specify a second condition as well as a second capture value. Okay, so here they have... Here I guess you could have like 2. That's fine. You can name item I as the popular short of index. The item is often the singular form of the item. Okay. Let's store the bits of binary number 1101 in little endian order. Least significant byte or bit first. Let's get back into the zig zone. Back into the zigger zone. Okay. Now we'll convert the binary bits to a number value by adding the value of the place as a power of 2 for each bit. See if you can figure out the missing pieces. No, we'll convert the universal size I to a... What was that again? Unsigned. Okay, so 4 bits. It's probably I, right? No. No. This can be I. What does it want here? Okay, it just put something. Okay. And it wants it to go 1101. So this should just be value. No. So, do we have to swap it again? Because I messed this up last time as well. This was not right. Okay. For items, this is the index. For bits in value. It's probably going to be terribly wrong. I need to get back into the mindset. Use of an undeclared identifier. Okay. Oh wait. Wait, not this time. Bit. I. Where are we? We did it. Okay. But what did we do? What did we do? Right, this bit here, it doesn't really explain what we did here. Should we ask Copilot? We'll turn Copilot on and ask him. We'll say, what does this do? A new one. We'll say, what does the in the following Zig code do? I mean, we achieved it, but only by copying this, right? In Zig, the 0 ... syntax is used to create a range that starts at 0 and goes up to the length of the items array. And in our case, that is the bits array. So it started at 0 and went up. This range is used to iterate over the indices of the items array. Okay, so we were just saying that we wanted to go through the array. Okay, through the index. Cool. I get it. I totally get it. That's nice. It uses your GitHub profile. Anyway, we don't need you anymore. Go away. Very cool. Now next one's another quiz. Uh-oh. Quiz time. Let's see if you can solve the famous fizz buzz. Players take turns to count incrementally, replacing any number divisible by 3 with the word fizz. Any number. Let's go from 1 to 16. This has been started for you. but there are some problems. That's wrong. Right, let's have a look at some compiler errors to see if we can figure it out. What kind of loop is this? A for or a while? This is going to be a while because this is not a boolean, and fors have to have booleans. So this is a while loop. While I is greater than or equal to 16, I is it continue? Yeah, that's fine. Print fizz. Then print. Okay. Let's have a look at a new compiler error. It needs to be public. No. Man. Oh, an idiot. Okay, cool. So that was wrong, and we fixed it. Now it's just this little bit here. Could say nothing, right? It's going to tell us what it wants, right? 2 fewer arguments. What does it want in here? Boom. Now where's the result? There you go. 1, 2, fizz 4, both fizz 7, 8 bit. We did it. Very cool. Quiz passed. Excellent. Let's share the stream because nobody's here and I'm learning all by myself. I think that will do. Okay. Next one. 18. Functions. We've already created lots of functions called main. Now let's do something different. Function foo n equals an unsigned 8-bit, and it returns n plus 1. The foo function above takes a number n and returns a number that is larger by 1. Note the input parameter n and return types are both U8. So this is the type for n, and this is the type for the return function. Okay. We have a constant of std, which is importing the standard library, with a public function of main. The new function deep thought should return the number 42, see below. Const answer, please define the deep thought function below. We're just missing a couple of things. One thing we're not missing is the keyword pub, which is not needed here. Can you guess why? Yes, because we're not printing anything. So this will be a function. And this function will be, it's 42, so it can be a U8 unsigned. Ta-da! Very good. I'm going to keep going until we've done all of these. Not today, but at some point. Is my camera frozen? It had frozen. What's going on? Okay, we went a little bit, that's fine. Cool. Next. Functions 2. Now let's create a function that takes a parameter. Here's an example that takes 2 parameters. As you can see, parameters are declared just like any other types. Name and type. Name and type. Name and type. Please give this function the correct input parameters. You'll need to figure out the parameter name and type that we're expecting. The input type is already specified for you. Function. You'll need to figure out the parameter name. Well, the name is my number. No. And what type we're expecting. This isn't right, but I want to run it and see what the compiler says. 25. If this is a name, annotated to type, my number equals T. Oh yes. What an idiot. What is T then? Oh, just type. Okay. It doesn't need to be U32, does it? No. Okay, well. This is a type. Give it a name. These are like contradictory, aren't they? We did it. Another quiz. Oh my god. The quizzes are hard. Okay, let's do it. Quiz time. Let's see if we can create... Oh, it's really small. No, it's not. Oh god. Let's see if we can make use of some of the things we've learned so far. We'll create 2 functions. One that contains a for loop and one that contains a while loop. Both of these are simply labeled loop below. Okay, this is correct. This is correct. You won't see this every day. A function that takes an array of exactly 4 unsigned 16-bit numbers. This is not how you would normally pass an array to a function. We'll learn about slices and pointers in a little while. For now, we're using what we know. This function prints but does not return anything. Well, if it prints, it needs to be public. And this here will also be. Let's see if the first one is good. 25. Binary operator has white space on one side, but not the other. Okay. This exercise bears a striking resemblance to the. Okay. I'm very confused. It's not telling me to do anything. I'm very confused as to what the actual problem here is. It says we'll create two functions, one that contains a for loop and one that contains a while loop. Where is print? Here's print power of 2. Oh. Whoops. Missed that pretty easily. The binary operator has white space on one side but not the other. Right. Let's have a look at some Zig binary operators. This documentation is fucking ugly, I'll tell you that much. Where's binary operator in here? No, let's have a look at this says we can do that. I'm not sure why it's complaining. Wait, is there more question marks in here? There is question marks. Fuck's sake. Two there. Are we ever even calling this? Oh, 2 there. Here we go. Return number. Return total. Curses. It's still complaining about this. Let's get rid of the comments. They make it a little bit more difficult. Get rid of these. Okay, line 25. Oh, okay. It's different this time. Now it's complaining. This binary operator. There is no binary operator here. It's complaining about this for some reason. I'm not really sure why. Is this just not correct? This is a... It should be correct. Where is N? Where is N? N is not defined. Oh. That's fine. N is this. And it's going to print powers of 2, which is this. And print powers of 2 takes my numbers. I don't like this error. This error isn't helping. Let's have a little Google of it, shall we? It's obviously pointing to an error somewhere else. Zig format. Okay, now we have something else. Now we have on 13. It wants this. We may need to seek help for this one. This one's pretty difficult. Let's ask Copilot. Let's say, hey, there's issues in my Zig file. Can you help? Okay, whoa. Incorrect loop variable. In print powers of 2, the loop should iterate over my numbers, not numbers. No, that was my fault. Actually, I did that. I broke it. In return value, it should return total, not number. Okay. This is not correct. It says this is the corrected code, but it's not. Okay, it is. Okay, let's figure out what the problem was. So it was public, like we said. Ah. Right, that's redundant. That's redundant. We did that. Oh my god. They called them loop. Oh my god. Right, we're doing that again. Jesus Christ. That was so stupid. So stupid. Jesus Christ. Okay, now we God, it's too early. It is like 10:50 here, to be fair. Okay. This is public, it prints. This is a unsigned 16-bit. But this is not fucking loop. Loop is not a thing. I wish it was just like this. But it does say they're simply labelled loop. I thought maybe there was some magic zig thing that does that. Okay, this is a for loop because it is going over an index. That's right. This again is an unsigned 16. But this is a while loop because while n is less than number, we add it and then we return the overall total because we're printing the powers of 2. Good lord. No. Okay. Okay. So what did we do wrong here? Oh, void. Why is it void though? Why is this meant to be void? Okay. I want to ask, why is the type void here? This is how you use AI. You learn. Use it to learn. We got a fan on me. It's cold as hell now. Okay. In Zig, the void return type indicates that the function does not return any value. Oh, because it doesn't. It just prints. Okay. This one's returning. So this one needs a return type. This is the return type. Okay. Okay. The function print _2 is designed to perform an action by printing, rather than computing and returning a value. Therefore, it is appropriate to use void as a return type. Okay. Thank you. Thank you, GitHub. Cool. Awesome. Now we can move on to learning errors. Very good. Apparently I can just like add a stream. I can add a new stream right now. Should we see? Enter an auth code. Oh no, my phone's all over here. Ah. Apparently we can start streaming on Twitter, on X, so I guess we try. Oh, my charger was turned off the whole time. That's super fun. Okay, auth. Twitter. Oh no, no, my phone shut down. Fuck. Okay. Maybe we can just tell it to give us an email instead. Okay, no, we can't stream on X right now. That's fine, I guess. Doesn't matter. Hey, Ashish. Sorry, I was trying to set up X streaming at the same time, but realised that it's not really required. So let's carry on. We just finished a super hard quiz, but now we're on errors. Now we're learning for a while. Look, no more quizzes. No more quizzes for a while. Okay. Believe it or not, sometimes things go wrong in programs. In Zig, an error is a value. Errors are named, so we can identify things that can go wrong. Errors are created in error sets, which is just a collection of named errors. We have the start of an error set, but we're missing the condition too small. Please add where needed. Well, probably here. Too small. And I'm guessing that's it. Oh no. So these are some errors. Well, it's all print errors. If the number is too big, if it's greater than 4, it'll say it's too big. If it's equal to, it's too 4. So this is too small. Oh no. What's the deal with 4s? Oh, idiot. If number error is equal to my number error dot too small, how would it know though? How does it know it's too big? Number error, number fail. Oh, here we go. Here we go. So it's down at the bottom. There's a function with a return type of my number error. If it's too small, return it. Yeah, cool. There we go. Awesome. On to the next one. Errors number 2. A common case for errors is a situation where we are expecting to have a value or something has gone wrong. Take this example. A variable of text. A variable called text equals get text. What happens if get text can't find the text document? How do we express this with Zig? The main purpose of Zig, I don't know, I guess. Let's have a look. Why Zig?
Everything to play for takes on its first.
Why Zig when already?
Versus Alex Ferguson. Would you
Let's
say?
Mute that advert. Jesus. Well, it's a compiled language, like Rust and C and everything. Why Zig when we already have these? There's no hidden control flows, no hidden allocations. I mean, I'll paste this in here for you. You can have a read while we learn some errors. It didn't send, apparently. There you go. Simplicity, apparently. I didn't even know D was a programming language. What the fuck? D-lang? Have you ever heard of D-lang before? I've never heard of D-lang. Okay. Well. Okay, so now we are going through errors. Ah, thank you. Wait, how did you find the stream then? I'm not accidentally streaming on Roadmap, am I? Am I accidentally streaming somewhere else? Oh, okay. Thank you. Yeah, I need to post more on YouTube. It's hard, but I'm trying to make at least one piece of content every day, whether it's a stream, a YouTube video, or a blog. So one piece every day should end up compounding over time. Anyway, what happens if the getText function cannot find the file? How do we express this? We can make an error union, which is a value which could either be a regular value or an error from a set. And we've done error sets before. Okay. Let's see if we can try making an error union. There is no error set here. Well, there's one error set. My number. So we're going to do my number error. My number. I think. It looks like my number will need to either store a number or an error. Okie dokie. Not right. my number is either going to store a number or an error. Now, this is to be a type. Is it a type? Because this is a type. Error unions, error unions. Let's have a look at some docs, shall we? Doesn't look like text is actually a return type, so let's have another little read, shall we? This is what it is. Variable text, if text equals get text. This one that could be it. That is not it. Get the error union type right. So there's an error union type. That's what we need. Error union type. An error set type and normal type of value. Union type. Where is it? Okay. It is a return type of an unsigned 64-bit, or okay, so we can do like an unsigned 8-bit. It's 5, right? Correct. Winner, winner, a shish. Winner, winner. We did it. You're not here anymore, though. Rip. Okay. Errors 3. One way to deal with error unions is to catch any error and replace it to a default value. Maybe we can try and add let's try stream on X again. Okay. At least I have followers on X, so maybe someone will turn up. Let's try to figure this out. turn on the old device. Come on. I need the Pixel 9, I think. I have an 8, and it's... I think since the 9 came out, it's like it knows, and it's got slower. Okay. Come on. Auth code time. Auth codes. Auth codes. Let's go. Faster, faster. Okay. Okay. That didn't do anything. That didn't do anything. What? Huh. Okay, it did, actually, apparently. I can also stream on X now, apparently. Okay. Okay. We are. Okay, cool. Now we're on X as well. Right. Errors number 3. One way to deal with error unions is to catch any error and replace it with default value. If can fail fails, foo will equal 6. Okay. So we just catch, I guess. Hey, Eric. Hello, hello. Wait, which Eric? Which Eric is this? Let me get a closer look. Wait, is this Eric? As in... Let me check here. I haven't seen you on... It is. It is. It's roadmap Eric. Zig's going okay. We have... I'm doing Zinglings. And we've done 22 exercises so far, which is pretty good. It doesn't feel that difficult, but we'll see, I guess. I want to do all of them. There is like 108, I think. There's 108, so we're doing errors at the minute. We're learning errors. There's a Golings as well. I'm pretty sure you know Go, right? But if you didn't know Go, there is Golings. Like, I find this broken exercise method to be pretty good at learning things. So I'll post that for you. Cool. Anyway, we're learning how to catch errors and replace it with default value. So this here should obviously be catch. Please provide the return type from this function. Hint, it'll be an error union. Okay. We already looked at error unions. Wait, I heard that. Why is my stream frozen a little bit? Is it just me? I missed the follow. I'm going to assume it was you, Eric. But I missed it because I froze a little bit. Let me make sure I'm not like massively actually lagging around. No, it's just Restream that pretends I'm lagging. Cool. You say you tried Rustlings. That to me says it didn't work for you. Error types. The return type is, okay, so it's going to be a 32, unsigned 32, error type. Boom. Did it. So A okay. I learn more when I build things. Oh yeah. I read that. That was really good. Well, I read the doc. Did you end up posting anything, like the actual code? Or is it still too dirty? Oh no, you have the source code. Okay. Fix it by cleaning it. Yeah. Very good. 100% Rust. Pretty cool, Eric. I'm not gonna lie. Pretty cool. Okay, cool. We fixed the catching bits, so let's have a look at the next one. Let me make sure that we are good. It seems that my stream is too large for the X app streaming. That's okay. Cool. Anyway, we're not streaming for a mobile users. It's not good. All right, I'll get rid of it. See you later. Gone. I've turned it off. Is it fine on Twitch? It looks okay to me. Yep. Okay, streaming fine for me. Anyway. Yeah, cool. I'll just stick with Twitch. Apparently it's bad to like multi-stream anyway because you don't actually get to build any type of following. Anyway. Completed. On 224. Using catch to replace an error is a bit of a blunt instrument. Correct. Catch lets us capture the error value and perform additional actions with this form. So we've caught the error. If there's an error, do something. the catch 0 below the temporary hack to deal with make just right's return error union for now. In this silly example, we've split the responsibility of making a number just right into 4 functions. Oh dear, this is missing a lot. Don't worry, it's nearly identical to fixing the above. If we get a too small error, we should return 10. If we get any other error, we should return that error. Otherwise, we return the unsigned 32-bit number. Okay. So, this is the return type, an error union, and no, idiots, that is wrong. We are going to catch an error, and then if the error if the error is too small, if the error is equal to my number error, if the error is equal to my number error too small, we should return 10. We should return. This is wrong. We should return 10. If we get any other error, we should return that error. Okay. So we just return the error. Potentially. Let's have a look. Correct. We are a genius. Huzzah. Yeah, I'm not streaming on X again. It's kind of crazy. Why no syntax highlighting? Eric, I'll do that now actually. Yes, but Twitch highlighted your comment as a possible harasser. You're possibly harassing me. How dare you? How dare you possibly harass me? Okay, I'm gonna fix that right now for you. Yeah. It says, look. Can you see this? Possible harasser. I don't know how to. I can't unharass you. So you're gonna stay there as a possible harasser. Yeah. Let's add some Zig highlighting. That'll make things a lot easier. Deprecated. Use this one instead. Cool. This should make things look very nice. Wait. Huh? Cool. It doesn't matter. Much better. Look at that. Far better. Cool. All done. Number 25. errors 5. Zig has a handy try shortcut for this common error handling pattern. We've caught an error, return an error, which can be more compactly written as try can fail. I don't know why I didn't have syntax highlighting before, this is so much easier. Okay. This function needs to return any error which might come back from detect. Please use a try statement rather than a catch. Where is catch? There's no catch. This needs to go away. Oh, this is terrible. Stop it. It's because I set up an alias. Oh my god. Go away. You can't even see this error, can you? So it's fine. I'll leave it off for you. Also, I just realised my OBS is like screwing me over. So, chat needs to be on top of the background. There we go. I'll live with the error for now. Cool. I'll live with the error. Oh, you're not a potential harasser anymore. That's good. Right. Let's try add 5. This will fail. This will definitely fail. Yeah. Also, I'm going to need to add steak. Extension is going to kill me if I keep saying that over and over again. Okay. Consider using try, catch, or if on 31. But I did use try. Right, let's try and learn this again. So what are we going to do, like try detect? Surely not. My brain's fried at this point. I'm not quite understanding this one very well. Okay, we have an error union here. This function needs to return any error which might come back from detect. Where is detect? Detect is here. And we're going to run add 5 and add 5 has detect in it. So that's fine. We need an argument. Okay, fine. All non-void values must be used. To discard the value, assign it to. Okay, well, this one's killing me. Okay, let's reset. Okay. Zig has a handy try shortcut for this common error handling pattern, which can be more compactly written as try can fail. Wait, so... Oh, wait. Jesus Christ. I hope you're not still watching, Eric, because that was embarrassing. All I had to do was add try, funnily enough. Sometimes I think things are more complex than they are. That's the problem. I didn't know it was as easy as just writing the word try once in one place. But, okay. Okay, I'm going to go to quiz 4. We're going to do this. Okay, great news. Now we know enough to understand a real Hello World program in Zig. One that uses the system standard out resource which can fail. Just take note that this main definition now returns a error union of void type rather than just void. Since there's no specific error type, this means that the Zig will infer the error type. This is appropriate in the case of main, but can make a function harder or even impossible to work with in some situations. You can find more information here. I do not like Zig's error, Zig's documentation. It's so ugly. Look at this. Look at this as a difference. Look at the difference here. Look. So much nicer. So much cleaner than this ugly documentation. Anyway, because too many functions in Zig return a possible error, Zig supports inferring the error set. Where is the inferred? Oh, here. This is the inferred error set. Okay. We get a writer for standard out so we can print to it. Unlike standard debug print, the standard out writer can fail with an error. We don't care what the error is, but we want to be able to pass it up as a return value of main. We just learned of a single statement which can accomplish this. Try. Try. It was try. We did it. Well done. Now to defer. You can assign some code to run after a block of code exits by deferring it with a defer statement. Okay, classic. This is used in... You can use this in Bash. Arik, did you know that? Defer statements in Bash. I believe it's called a trap. Trap statement. I'm not sure. Bash trap. Or is this something completely different? Trap. Oh no. It will not execute the exit trap function. Probably not the same thing. I'm sure. What is this for? What, trap? Trap's different actually. I thought trap was the same as deferring. We're going through deferring now, which I'm sure you're familiar with. You defer this and it has to run after something else. By deferring it over the first statement, yeah. In the above example, you can have defer in Bash, I'm sure. Let me have a look. I've used this to like clean stuff up, I'm sure. Maybe not. Anyway, it doesn't matter. This feature seems strange at first, but we'll see how it could be useful in the next exercise. After the block is finished. Okay. Without changing anything else, please add a defer statement to this code so that our program prints 1 over 2. Okay. There you go. Done. Yeah, I can't remember when I used defer before. I've used defer before, not in a language like this. I don't know when, to be honest. But it doesn't matter. Defer to. Now that you know how defer works, this is more interesting. You have a unsigned 8-bit array for the animals in this index. Well, for A in the index of animals, print A. So it'll go G, C, D, D, G, Z, which it has done here. G, C, D, D, G, unknown. There you go. If G, C. Cool. This function is supposed to print an animal name in parentheses like goat, but we somehow need to print the end parentheses even though this function can return it in 4 different places. So it needs to do this. How can we do this? Well, probably by deferring it, I'm guessing. That's probably what you want me to do. We did, but why? Like, this Zinglings thing is good. But my problem is, it doesn't explain things enough. Like here, it's not explaining properly what happened here. It's just not. So, if we defer, printing a closed parentheses. Oh, it's to everything. So it will print. Okay. Okay, I get it now. Yeah. So it's always going to print this first. We're deferring this to the end. So it will print this, and then the animal, and then this. Okie dokie. I get it. Error deferring. Another common problem is a block of code that could exit in multiple places due to an error, but it needs to do something before it exits. Typically clean up after itself. An error defer is a defer that only runs if the block exits without an error. With an error. Error defer, cleanup. The cleanup function is called only if the try statement returns an error produced by can fail. I like that, that's very clean. We simply quit the entire program if we fail to get a number. So, if it doesn't work, we just return and fail. We exit. Please make the failed message print only if the make number exits with an error. Well, we know this is a defer error. Oh, it's an error defer, not a defer error. Awesome, awesome. Why does it have my okay, it doesn't, that's fine. My own stream is it's frozen, but I know we're not frozen because I can see it on Twitch, so that's fine. We are going to need to charge though. Let's plug in the charger and get super hot. Okay, next one, number 30. Almost at the last quiz. Well, quiz 4. The switch statement lets you match possible values of an expression and perform a different action for each. Yes, we know this. This switch is equivalent to this if else. If player 1, start. If else, player equal 2. Else, do this. Yes. Switch statements must be exhaustive, therefore there must be a match for every possible value. Please add an else to this switch to print a question mark when C is not of the existing matches. Okay. Please add else. So else please add an else to this switch statement to print a question mark when C is not one of the existing matches. Well, it's doing it for me now. I don't want this. I'm turning off Copilot. Go away. You're not helping me. You're not helping me learn, Copilot. It's probably not even going to work. It's lying to me. Okay, it did work. Fine. That's the problem, isn't it? You could sit here and you could use Copilot to solve all of this, and you'd learn nothing. You'd learn absolutely nothing. Okay, switch 2. What's really nice is that you can use a switch statement as an expression to return a value. So the constant of A is a switch value. Is a switch statement, sorry. Please add the else clause, and this time have it return an exclamation mark. Okay, so else. Why is it auto-completing? I don't like this. Note C forces print to display the value. Yeah, I just turned it off. Wait, it's not off again. Disable completions for Zig. Let's try that again. Yes, it's turned it off. We want to print an exclamation mark. Note, C forces print to display the value as a character. Can you guess what happens if you remove the C? Try it. It printed the numbers. It printed I and then a 0. That's very strange. Okay. Why did it print? This is the thing. It told me, it says, I'll remove this and then give it a try, right? Can you guess what happens? It doesn't tell me why it does this. So I am gonna ask Copilot why. Why did my Zig code return like otherwise how am I gonna know? You know? In Zig, the font writer is used for general purpose printing, which defaults to printing the integer value of the character. To print the character yourself, you should use C. Here's the correct thing. Oh, it's the ASCII values. So, is this Zig in ASCII? Is that what it's telling me? Let's have a look. ASCII translator. Oh, that's far too much. Convert text to ASCII. I mean, close enough. Close enough, but yeah, that's what it was doing. Okay. That's cool. Now I understand. Unreachable. Zig has an unreachable statement. Use it when you want to tell the compiler that a branch of code should never be executed and that the mere act of reaching it is an error. Here, we've made a little virtual machine that performs mathematical operations on a singular. It looks great, but there's one little problem. The switch statement doesn't cover every possible value of an unsigned 8-bit number. We know there are only 3 operations, but Zig doesn't. Use the unreachable statement to make the switch complete, or else. Okay. So are we just gonna do like unreachable? No. Are we going to do like else unreachable? Surely not. We are. So what we're saying here is if it isn't 1, 2, or 3, then it's unreachable. Okay. If error... Let's revisit the very first error exercise. This time, we're going to look at an error handling variation of the if statement. If the variable with the value... It's not an error, the value wasn't an error value. It was an error. Error is the error value of who. We'll take it even further and use a switch statement to handle the error types. Okay. Please add a match for too small here and have it print. This time we'll have number. It's returning an error union already, so that's fine. Please add a match. Please add a match for too small here. Okay. Okay, cool. Final quiz time. Final quiz. See if you can make the program work. Solve this any way you like. Just make sure the output is my number equals 42. Okay. Okay. This function is obviously weird and non-functional, but you will not be changing it for this quiz, okay? So we're only changing this one. Get number. Let's see what it's outputting. It's outputting unexpected type of unsigned 32-bit found. It says we're not going to change that, so that's fine, I guess. $15. Okay. Make it work. It does say solve it any way you like. So, print my number dot my num. My num is get number, which returns 42. So why is this not working? It's this. Expected a unsigned 32. Ooh, we could catch. We could just do a catch. It says I can do it any way I like. So, where's catch? Catch. You could literally just like catch 42. No? Okay. Return an error. Oh. Okay, no. Control. Okay, well. I can avoid, I guess. It's fine. I thought the catch might work, but it didn't. It didn't work. Wait. You did it! Yes. It said, solve this any way you like. So I just put a catch statement to make it 42. So there we go. Winner, winner. How long have we been going for at this point? It's hour 43. Oh god. should probably go. Or do one more. I'll do one more. Wait a minute. What was that? Megalo? Thank you. The stream that I look at lags. So I hear the noise, but I didn't see it. But I do see it now. I think. Yes, I do. Awesome. I was potentially about to end, but I will do like 2 more because you've just joined and just followed. So I'll do 2 more. Let's learn the enums, the enumeration ones, and then we'll go. Cool. Remember that little mathematical virtual machine we made using the unreachable statement? Well, there were 2 problems with the way we were using opcodes. Having to remember opcodes by number is no good. We had to use unreachable because Zig had no way of knowing how many valid opcodes there were. An enum is a Zig construct that lets you give names to numerical values and store them in a set. They look a lot like error sets. Okay. Okay, wait. Let me have a look at something quickly. Okay, cool. Right. Let's use, well, here. It's a construct that lets you give names to numeric values and store them in a set. They look a lot like error sets. So fruit, enum, apple, pear, orange. Fruit, apple. This will be 0, I assume. Let's use an enum in place of the numbers we were using in the previous version. Okay. So this enum should be what? Ink, pow, and deck? No. Yes. Ink, pow, deck. No else is needed. Why is that? That is because we are defining it is because before we had to use unreachable because Zig had no way of knowing how many valid opcodes there were, but now we're giving it a way of knowing, so we don't have to use else. Awesome. Done. Right. One more. Because we've done a lot today. We've done like so many. Cool. Enums. Or I could go all the way to quiz 5. I don't know. I'll see what happens. Enums are really just a set of numbers. You can leave the numbering up to the compiler, or you can assign them explicitly. You can even specify the numeric type used. Stuff equals a enum of unsigned 8-bit, and they have set foo to equal 16, which is an unsigned 8-bit integer. You can get the integer out of a built-in function, like this. We'll learn more about built-in functions in later exercise. Okay. Note how that built-in function starts with an @ just like import. Okay. Zig lets us write integers in hexadecimal format. Web browsers let us specify colors in hexadecimal format. Please define and use a pure blue value color. I'm I'm gonna have to find this, right? He's not gonna tell me. I'm gonna have to find this out. Okay. How would I do this? Please define and use a pure blue value color. Am I gonna have to just Google this? Oh, here we go. American English, apparently. Please define and use it. Okay, so let's find out. Let's find out what the hexadecimal format. Without looking it up, I'm gonna make a bold assumption. And it's this. I was expected this. That's what I put. What? But found this instead. Oh. Does it want us to put RGB? It's different here, that's why. Do you remember Zig's multi-line strings? Here they are again. Also, check out this cool format string. Please add this formatting to the blue value. Even better. Experiment. Oh, I need to add it in here, okay. Experiment without it. Okay, so we'll try this. This will work, I assume. It did work. So it was defining a lowercase hexadecimal. This is a separator, padding, alignment. Okie dokie. Let's do one more. One more. Just one more. Okay. One more. Being able to group values together lets us turn this into this. 0.1, 3, 16, 27, 3, 16, 27. The point above is an example of a structure. Here's how that structure type could have been defined. Let's store something fun of a struct in a role-playing character. We'll use an enum to specify the character role. Please add a new property to this structure called health and make it a unsigned 8-bit integer type. Okie dokie. Health. Unsigned 8-bit. Please initialize Galorp with 100 health. Okay. Glorp gains some gold. Ouch. Glorp takes a punch. Okay. Okay, your wizard has 90 health and 25 gold. So you gained gold. Very cool. Okay, I could do this all day. Yeah, I'm going to go to Arik, so goodbye. I'll see you at work or on a stream again. Goodbye. I'm also going to go, because I have been on here for a long, long time at this point. I have no idea how to end this stream, but I'll figure it out. Awesome. Cool. Right, we did... How many did we do? We did a lot. We did a lot today. I don't know how many we did. I think we did... We did Fizz Buzz today. We did a lot. We did a whole lot. We're on 37 now. And we'll keep doing this and keep continuing with it.